Let's represent the largest amount of energy. Options are electron volt, joule and calories. As the calories defines the highest amount of energy, the correct option is D. The absolute enthalpy of neutralization for the given reaction will be less than the minus 57.33 kilojoules per mole, minus 57.33 kilojoules per mole, greater than minus 57.33 kilojoules per mole, or 57.33 kilojoules per mole. Now the correct option here is A, that is less than minus 57.33 kilojoules per mole, as there is some amount of energy which is required for the work. Heat of neutralization of strong acid by a strong base is constant value because salt form does not hydrolyze. Only H plus and OH minus ions react in every case. The strong base and strong acid react completely. The strong base and strong acid react in aqueous solution. The correct option here is C, as the strong base and strong acid react completely. Therefore, the heat of neutralization is constant. Heat of neutralization of an acid by a base is highest when both the acid and base are weak, both the acid and base are strong, the acid is strong and the base is weak, the acid is weak and the base is strong. The correct option here is when both the acid and base are strong. Which is the best definition of heat of neutralization? Option A, the heat set free when 1 gram molecule of base is neutralized by 1 gram molecule of an acid in dilute solution at stated temperature. B, the heat absorbed when gram of molecule of an acid is neutralized by 1 gram molecule of a base in dilute solution at stated temperature. The heat set free or absorbed when a normal solution containing 1 gram equivalent of an acid is neutralized by normal solution containing 1 gram equivalent of a base at a stated temperature. The heat set free when 1 gram equivalent of an acid is neutralized by 1 gram equivalent of base in dilute solution at a stated temperature. The correct option over here is D. Calculate the standard heat of formation of carbon disulfide. Given that the standard heat of combustion of carbon sulfur and carbon disulfide are minus 393.3, minus 293.72 and minus 1108.76 kilojoules per mole. So we need to find out the bond formation for carbon disulfide, which goes on from the following reaction. Now the formation takes place through various steps. That is, first the formation of carbon dioxide, where the change in enthalpy is minus 393.3 kilojoules. Then the formation of sulfur dioxide, the formation for the sulfur dioxide is associated with the heat change of minus 293.72, and the final reaction is associated with the change in enthalpy of minus 1108.76. Now multiplying equation, let's name the equations 1, 2 and 3. Equation 2 by 2, and when the equation 2 is multiplied by 2 and is added on to equation 1 and subtracted from equation 3 to get the desired standard heat of formation of carbon disulfide, the final answer we get is, so the correct option we get over here is plus 128.02 kilojoules per mole. So the correct option is option C. For the given reaction, we have to find the delta H value. Reaction, we need to find delta H. Now here we have to add equation 1, that is this. Let's name equation 1. and this one, that is equation 2. Adding equation 1 and 2, we get minus 196 upon 2, which is minus 98 kilocalories, and the correct option over here is C. The following thermochemical reactions are given below. It follows that the heat of reaction for the following process is given by option A 422.2 kilojoules, option B 268.7 kilojoules, option C minus 442.2 kilojoules, option D 260.6 kilojoules. Now here equation 1 minus 2 will give us the heat of reaction, and the correct option over here is D, that is 260.6 kilojoules. Enthalpy of neutralization of acetic acid by sodium hydroxide is minus 50.6 kilojoule per mole, and the heat of neutralization of a strong acid with a strong base is minus 55.9 kilojoules per mole. What is the value of delta H for the ionization of acetic acid? Now here delta H, that is enthalpy of neutralization, is given by enthalpy of the ionic state plus delta H of the neutralized state, which is minus 50.6 plus minus 59.9, which gives the value of minus 5.3, and the correct option is A, that is plus 5.3 kilojoules per mole. When 400 ml of 0.2 normal solution of a weak acid is neutralized by dilute aqueous solution of sodium hydroxide under standard conditions, 4.4 kilojoule amount of heat is liberated. Therefore, the standard enthalpy is of neutralization of this weak acid in kilojoule per equivalent is given by, now here the number of equivalents of a weak acid is given the multiplication of the 0.4 into 0.2, that is 0.2 normal, and the ml given, which gives the answer of 0.8. Now the heat liberated is given by minus 4.4 divided by 0.08, which gives the answer of minus 55. Now here the sign is negative as the heat is liberated and the reaction is exothermic. Given the following reaction, the heat of formation of NCl3 in terms of delta H, delta H2 and delta H3 is, now here let's name the equation this as 1, 2 and 3. Now we have to multiply equation 2 by half and add to the equation 1. We have to multiply equation 3 by 3 by 2 and subtract from equation 1. So that gives us delta HF, that is enthalpy of formation, delta H1 minus delta H1 minus delta H2 divided by 2 minus bracket plus 3 by 2 delta H3, which gives us the final answer as minus delta H1 minus delta H2 by 2 minus 3 by 2 delta H3, which is the option C. In which of the following pairs the enthalpy of neutralization is less or more than the standard value? Now here the correct option is when the enthalpy of strong acid and base is nearby the standard value. Therefore the correct option is HCN, as the base over here is strong and acid is weak. The standard enthalpy of formation of NH3 is minus 40.0 joules per mole. if the enthalpy of formation of H2 from its atom is minus 436 kilojoule per mole and that of N2 molecule is minus 712 kilojoule per mole, the average bond enthalpy of NH bond and NH3 is. Now here, going for the reaction for the formation of the ammonia, that is NH3, the reaction is given as follows. Going for the standard enthalpy of formation, that is minus 40.0 joule, the enthalpy of formation can be given by enthalpy of formation of NH3 minus enthalpy of N2 molecule minus 3 by 2 enthalpy of H2 molecule, which gives us the final answer of 1056 kilojoules per mole on substituting the values, and the correct option is D. Delta G0, that is standard Gibbs free energy for the reaction X plus Y is equal to Z, which is reversible reaction, is minus 4.606 kilocalories. The value of equilibrium constant of the reaction at 227 degrees Celsius is. Now going for the formation of the free energy, going for the relation between the Gibbs free energy and the equilibrium constant, the equation can be given as, substituting the values, the final value of K we get is 100. So the correct option here is A. For a reaction at 25 degrees Celsius, enthalpy change and entropy change are minus 11.7 into 10 raised to 3 joules per mole and minus 105 joule per mole per Kelvin respectively. What is the Gibbs free energy? Now here we have formula delta G is equal to delta H minus T delta S. The temperature here is given as 25 degrees Celsius, which is 298 Kelvin. Substituting the given values in the formula, we get the final answer as 19,590 joules, which is equal to 19.59 kilojoules, and the correct option is B. The correct reaction between equilibrium constant K and standard free energy, that is delta G 0 and temperature T, is given by, as we know the formula, delta G 0 is equal to R ln K. So the correct option over here is D. Now here when we convert the natural logarithm to logarithm, the value we get is 10 raised to minus delta G0, that is the standard Gibbs free energy, upon 2.303 RT. So the correct option over here is D. At the sublimation temperature for the process given, the correct option we get here is when delta H is greater than 0, delta S is greater than 0, then the Gibbs free energy is equal to 0. So the correct option here is E. For 18, for a hypothetical reaction A to B, the activation energies for forward and backward reactions are 19 kilojoule per mole and 9 kilojoule per mole respectively. The heat of reaction is given as, now delta H, that is change in enthalpy, is EA for forward reaction. This EA is the activation energy and it is minus EA for backward reaction. So it is 19 minus 9, that is 10 kilojoule, and the correct option is C. For the given reactions, the change in enthalpy for graphite is minus 94.05 kilocalories per mole, and for diamond is minus 94.5 kilocalories per mole. Now therefore, the options given below, the most suitable option here is that the graphite is the stable allotrope, as the change from the enthalpy of graphite and enthalpy of diamond, the transformation energy is only minus 0.5 kilocalories. Therefore, graphite is the stabler allotrope. For the process dry ice to CO2, that is in the gaseous form, the correct option here would be both delta H and delta P are positive. Five moles of a gas is put through a series of changes as shown graphically in cyclic process, the A to B, P to C, C to A respectively. Now here from A to B, the temperature is changing, the volume is constant. Therefore, the first process is isochoric. From B to C, here the temperature is changing, the volume is also changing, but the pressure is constant, so it is isobaric. From A to C, the temperature is constant, the volume is changing, and the pressure is also changing, so it is isothermal. So the correct option here is option A. For 22nd, which of the following thermodynamic relation is correct? Now let's consider the change for the Gibbs free energy, that is H minus Ts. H, that is enthalpy, is also given by E plus PV, that is internal energy plus the work done by the pressure and volume. Substituting this value in equation 1, we get, now let's differentiate. Now as we know, dE is also given by dQ plus dW, that is the heat involved and the work done. Now dW in expansion is minus PdV, that is the work done. Therefore, dE becomes dQ minus PdV. dQ, that is heat, is also known as TdS. Therefore, dE becomes TdS minus PdV. Substituting this equation in this given equation, we get dG is equal to TdS minus PdV plus PdV plus VdP minus TdS minus SdT. Now here the terms with opposite signs get cancelled, and the final term which is left is VdP minus SdT, and the correct option here is A. The incorrect expression for the following is, from the formula we know delta G0 is equal to delta H0, that is standard enthalpy, minus T delta S. Now delta G0 can also be written as minus RT natural logarithm K. Now natural logarithm K can be given as delta H0 minus T delta S0, that is standard entropy, upon RT. So the correct relation over here is C. At 300 Kelvin, the reaction which have the following values of thermodynamic parameters occurs spontaneously. Now this is an example of multiple answers, and the correct answer here would be, according to the question, delta H should be positive, delta S should be negative for the reactions to occur spontaneously, and therefore the correct options over here are A, wherein the delta H is positive, delta S is negative, therefore delta G, that is free energy, is in negative, so that the reaction occurs spontaneously. The C and option D, where delta H and delta S are negative, positive respectively. Among the following, the intensive property is molar conductivity, electromotive force, resistance, heat capacity. This is also an example of the multiple answers. Here, molar conductivity and electromotive force are independent of the amount of mass present, whereas resistance and heat capacity are dependent on the amount of matter present. For an ideal gas, consider pressure volume work and given from an initial state x to the final state z. The final state z can be reached by either of two paths shown in the figure. Which of the following choices are correct? Take delta S as change in entropy and W as work done. Now here, looking for the options, A, that is change in entropy from x to z, has the pathway of the change in entropy from x to y and y to z. Therefore, this option is correct. The work done from x to z is given by work done from x to y and y to z. This is an incorrect option, as the work done is from x to z directly, and it is a state function. The C, the work done x to y is equal to the work done to the x to y, which is also an incorrect option. The last option is the change in entropy from x to y, y to z is the change in entropy from x to y. This is a correct option, and therefore the correct answer we get is A and D. The reversible expansion of an ideal gas under adiabatic and isothermal condition is shown in the figure. Which of the following statements are correct? Now looking on for here, let's consider statement A. Here it is shown that T1 is equal to T2. That is, it is isothermal. Option B, T3 is greater than T1. Now this is not isothermal, and therefore it will give the cooling effect. Option C, where work done in isothermal condition is greater than work done in adiabatic condition. Option D given is the change in the internal energy of isothermal is greater than the change in the internal energy of adiabatic condition. According to the sign conventions, option C is not valid, so the correct options are A and D.